Hi, I'm Vinod. In the previous videos, we looked at the evolution of the chip over the years. In this video, we will look at the activities involved in the chip making process. A company designs and manufactures a chip based on the analysis and requirements of the market. An architect uses the market requirements document to come up with the architecture specification of the chip. To design a chip, a company would have design teams and verification teams. The design team uses the architecture specification of the chip to prepare the design specification and to write a set of RTL files. This means that they write down code in a hardware description language that completely captures the functionality of the chip. We will look at RTL in detail in the coming videos. In parallel, the functional verification team uses the architecture specification and the design specification to develop a software environment that checks if the chip works as per the specification. And it is usually built using System Verilog language. The environment has code to generate and provide various inputs to the design, checkers to check the correctness of the design, and trackers to track the verification's progress. The process of running the design in the verification environment is called simulation, as this is essentially simulating the planned hardware's behavior. The key thing to note here is that simulation or functional verification is done assuming there are zero gate delay. Once the design team is ready to release their RTL code, the code is provided as input to a synthesis tool. This tool takes the RTL code and implements it in logic gates. The output of the synthesis process is called netlist. Netlist is also a System Verilog file. It is a gate-level implementation of the design, and it contains the functionality of the chip in the form of a set of logic gates. Members from the verification team verify that the gate-level netlist behaves the same as the RTL. This process includes gate-level simulation or GLS. Gate-level verification not only takes care of checking the functionality of the chip, it also takes care of the timing requirements of the chip. Transistors that make up a chip have switching time, which adds up during a logic implementation. Gate-level verification should check that the combined switching time of each logic implementation is within the acceptable limits as specified by the requirements. At the same time, another team places these logic gates within the dimensions as defined by the specifications of the chip. For example, the dimensions could be 10 mm by 10 mm. This process is called the physical design of the chip. The members of the verification team verify that the physically laid out gate-level design functions as per the specification and that this design meets the timing requirements. The verified netlist is sent to the chip manufacturer who fabricates the netlist to create chips. The process of sending the netlist to the manufacturer is called tape-out. This process is called tape-out as the netlist was sent to the manufacturer in magnetic tapes during the early days of chip development. Initially, the manufacturer manufactures only a small number of chips. These sample chips undergo a process known as testing. Testing is the process of checking the correctness of the manufacturing process. Next, the chip manufacturer sends the manufactured and tested chips back to the designing company. The designing company goes through the process of validating the chip. Validation is a process that ensures that the actual chip is functioning as per the specification by verifying its functionality in a lab. Once the validation of the chip is complete, it is ready for mass production. To summarize, the steps involved in the design and manufacture of a chip are as follows: architecture specification, design specification and RTL design, functional verification, synthesis, gate-level simulation and verification, physical design, fabrication, testing, and finally, validation. The timeline of the chip making process varies depending on the size and the complexity of the chip. For large chips with high complexity, the process might take between 18 and 24 months. On the other hand, smaller chips can be made in 1 year. In the next video, we will look at why companies make chips. Happy learning.